Alright, here we go with another alternator video. A quick video for somebody that was asking how do they tell the difference between a small case and a large case. For me, the first thing that I notice is the three ribs on the front on the small case, and the large case will have the four ribs plus the center support. That's an immediate way to tell right off the bat a large from a small case. Now, from the back side, you'll always notice that the large case has a heat-sinked rectifier. It's got a lot of fins. Well, they both have heat sinks, but this one's finned. And you'll visually be able to see the fins from the outside on the rear of the case. Excuse my hiccups, guys. Versus your small case, you might think that that's heatsink part right there, but that's actually the brown plastic from the Denso rectifier in there. It's where the leads from the stator go up through and terminate to the rectifier plates. That's the way I tell a small case from a large case from the rear. Super quick, super easy. If you don't see heat sinks, it's a small case. If you do see heat sinks, it's obviously a large case. Three ribs on the front case is a small case. Four ribs on the front is a large case. All right, so that's the external difference. Internally, they're vastly different. To kind of give you an idea, this is the size of the rotors. Now let's set these guys up. Kind of gives you a pretty good idea of the size difference, and that's why large cases do so much better. It's only a 10 millimeter difference, but there's also a difference in width. Jesus, these fucking hiccups. Excuse me, guys. I apologize for that. Small case stator, 128.5 millimeters in diameter versus your large case, which is 138.5 millimeters in diameter. Exactly. Literally a 10 millimeter difference. The thickness of the stator stack on the large case and the girth and the weight mass of the rotor and the windings inside of it make a large difference in idle. The small cases are capable of doing some pretty substantial power at high RPM, but you have to spin them. So you're talking, above 2,000 RPM to get full output or near full output from a small case. Versus the large case, you do have to spin them as fast to get their maximum output, but this large case will absolutely run circles around a small case at idle and at cruise speed. To make this quick, getting into the rectifier setups, this is a factory Denso unit. This is from everybody's favorite alternator manufacturer. I won't mention the name. This is a factory small case. These are two large case ones, obviously, with the fins. This is a factory high amp, or a 160 or a 150 unit. Out of a Nippon Denso alternator. That's actually factory OEM Japanese. This is an aftermarket, what I use in my rebuilds for the small cases if people must have a small case, which I would always recommend a large case for obvious reasons. But this is a pretty good unit. 80 amp diodes, they're much larger than your factory ones. I would imagine this is a little bit more rugged, pretty good. I've tested quite a few of them. This seems to be the best performing one that I've found yet, even over a copper version. This is the factory one that came out of my Scion when it was built from the Toyota plant, wherever the hell it was built, probably in the United States somewhere. But the actual alternator was made in Japan. This is a Japanese unit, but look at, if you notice, there's missing diodes. There's three missing diodes on that top plate, the positive plate, and there's three missing diodes on the negative plate. Pretty cheesy. It did good. It worked. Did it get the job done? It did. But very high resistance connection, ran extremely hot. I'm actually surprised I never got it to fail, because I did abuse the shit out of it. A couple differences in the rotors too. There's a large case and a small case, but there's different ohm rotors. This is a 1.8. They come in a 2.2 as well. This is a 2.2. They also come in a 1.8. Both same resistance readings on the coils for the rotors, but they do have different outputs. The lower ohm rotors are able to pull more power and make more magnetic force, which equals more power. So the difference between the width and the girth of the rotor, the difference between the mass and the size of the wire, the cross-sectional size of the wire itself. I'll get in on that a little closely. You can actually see the difference in the size of the wire. The small case has much thinner wire. It's about half the size almost. And the large case obviously is able to carry more current. differences in the stators, real quick. There's 3 different configurations. There is the series configuration, which is stock, which both of these are in that configuration now. Then you modify this portion, this quadrant of windings, to be parallel with the other 2. This is a half winding, and this is another quadrant. So you parallel this with those 2 guys that are in series. These will be in series. This would be paralleled with those. That makes a 240. If you parallel both of these with the other half, so all 3 being in parallel, that makes a 320. But you have to spin the shit out of it to get 320. And we're talking like way over 2,000 RPM. You have to fucking spin the crap out of it. And they get hot. You start loading them down pretty heavy, and they get really, really hot. I've had this up to about 400 degrees for testing. I don't recommend you guys do that. That's near the failure point of the epoxy that coats the wire and the windings that are in the stator. I don't recommend that you do that, but I do that just to make sure that, you know, any units that I send out the door are going to pass the ultimate grueling test should the customer decide to do that. Same exact thing with the large case. You just parallel the quadrants. One paralleled with the other 2 makes a a 320 from a 270. Both of these paralleled with that other half, all 3 being in parallel, will make a 370 amp, which I've bench tested. There's videos on my channel of the 7.3 Super Duty with this actual alternator right here in it doing 388 amps. But that's the difference between your large and small case. The aesthetics from the outside, to be able to visually decipher between the 2, the internal parts and why they do what they do. I will always recommend a large case over a small case, just for the simple fact that it just has more output. To give you an idea, the small case will do about 130 non-modified, so in the stock configuration, which is the best idle output. At a 240 configuration, which this alternator is currently, a standard 240, you're looking at about 90 amps hot at idle, which isn't all that great. That's 40 amps less than a stock unit, and even less than that on the 320s. You just have to spin them fast, man. That's the only way. Put a baby pulley on it, spin it as fast as you can. Hopefully it's good enough. They usually are. Most people aren't pulling the crazy amount of wattage or us car audio guys are. So I mean, that will suffice for anything smaller than, you know, than what larger systems run. I've got about 10,000, a little over 10,000 watts on tap, and this guy just doesn't have the mustard to keep up. And large case certainly does much better. So anyway, if you guys are interested in any technical, if you have any technical questions, if you want to see a video of a build, maybe the next build I do, I'll do a little time-lapse video or something where you guys can see the parts that are being used and how I put them together, and just the little things that I do to make them better, such as filing off like that little nub right in the center of your screen there. That's going to keep this rectifier plate from sitting flat on the back of the rear alternator case, which is going to potentially lower current conductivity and therefore power output. That little guy needs to be ground off. This is America's favorite alternator manufacturer, aftermarket Chinese transpo. Here's a factory Denso. You notice in the same spots where the rectifier actually sits on the alternator case, it's all flat for maximum conductivity. It's pretty important centering the rotor inside with the washers to make sure that the rotor is exactly centered within the stator stack. Little things that, bless you, baby. Things like that make an absolute huge difference when you're trying to get the most output from these things as you can. And that's what everybody's trying to do in the car audio world anyway, and that's why I decided to get into it, because I wanted to build my own. Bless you, babe. Are you allergic to my discussion here? Jesus, Murphy. She's allergic to fucking alternators, guys. Anyway, so, the reason why I even got into this is because nobody made a large case for my car, and I wanted to figure out how they worked and how to build my own. So I just kind of did a little bit of research. I've got a few alternators out there doing some good amperage. We have yet to see longevity and whatnot, but I'm pretty confident that they're good. But if you guys are interested in anything, just leave a comment below. Or if you guys are interested in getting an alternator done, email me at Srisomsak. It'll be my first initial, last name at gmail.com. gsrisomsak@gmail.com. And we'll get you guys set up. Thanks for watching. We'll talk to you soon.